9.6, solving right triangles. So, trig ratios was like learning how to sit up before you learn to walk. Today you're going to learn how to crawl, and then eventually learn how to walk. Okay, so it's a very important lesson. I have moved your test to February 15th. It's a Thursday. It's been approved. A Thursday.
What?
I asked the powers that be, and they said since it is math, and I'm telling you 2 weeks in advance, that is okay. It's the day after Valentine's Day.
Is it being math?
Because you have all told me adamantly that you do not study for math. So
Oh, yeah, that's true.
Correct.
that's true. So then there's no difference in it being on a Thursday. So it will be, it will be 3 Fridays from now. Sorry, 3 Thursdays from now. Just so you know. So today we're going to start on our notes. You want to find the screen that looks like this on your notes. You might have to flip a little bit because I reorganized after I printed them out. So, today, you're going to learn what we call the inverse trig ratios, okay? Inverse trig functions, even. So, an inverse in math undoes, or undoes, I don't know, something, undoes, I don't know. Like addition, what is the opposite of addition? Subtraction. What's the opposite of multiplication? Division. So you're going to learn the opposite of tangent, cosine, and sine. Okay? The number one thing I want you to write down is in all capital letters across the screen. You don't have to write it across your screen or across your paper, but somewhere on there it needs to be emphasized. To find missing angles given the trig ratio, you will use inverse, and you'll see why. It is a button on your calculator, and it is very simple if you know when to use it. If you don't know when to use it, you're just walking around blindfolded, and that's ridiculous. So, to find missing angles given the trig ratio, you will end up using the inverse function. Usually requires your pencil. To find missing angles given the trig ratio, you're going to use the inverse function. Okay, so as an example, write it on the board. Can you see a marker? What we just did before, with our first example, can y'all read that? Marcellus, can you read that? Yes. Okay. So tangent of our example before we started class, tangent of k, what was it? I don't remember. Was it 15 over 17? 8 over 17. Just flip back to that paper.
8 over 17.
8 over 17.
8 over 15.
Okay, 8 over 15. Either way, so you have learned up until this point to set up an equation that looks like this. It's called an equation because there's an equal sign. All right? So what happens is you're going to learn the next step. What does the capital K represent? The angle. It's missing. You don't know it. But because of you setting up a problem that looks exactly like this, you can definitely find it. It takes 2 buttons in your calculator. So it's called the inverse. I will show you which buttons. So pick up your calculator. Yep. You want to make sure in the screen, that there is the letter D is lit up. It represents the word degree. If it is not degree, you will not get the same answer that everyone else is getting. So does everyone say that at the top of their screen?
Yes, ma'am.
Sweet. So after that, all you do is you hit Shift. Shift is in the top left. And then we're going to use the inverse of tangent first. So you're going to hit tangent. Do you see in yellow it says tan to the negative 1? That is called the inverse of tangent. So what you should have pop up, it will say tan to the negative 1, right? And it open a parenthesis. This is the inverse of tangent because the angle K is attached to tangent. You want to get K by itself, you have to do the opposite action, the inverse to it. So the inverse would be tangent to the negative 1. So, it's read as the inverse tangent of x in this problem. But there's also one for sine and cosine. Okay, on your notes, this box that says reading is not filled out. So you will fill it out. It is read as the inverse tangent of x. Well, that's funny too. So you're going to write that down in that box. It is read as the inverse tangent of x. So it says tangent to the -1. But those of us in the math universe call it the inverse of tangent. So we have currently, on the screen, have tangent of k equals 8/15. To solve for k, you need to get rid of tangent. You have to use the inverse of tangent. So you'll hit that second, or that shift tangent, and a parenthesis will open up. Now you're going to type in 8/15, or 8 divided by 15. And hit equals. For the most part, you're going to be rounding to the nearest tenth. What do you get? Tenth is 1 decimal place. 0.1 degrees. So, this is why I say you're learning the very next step. You know how to set up a problem like this. You use the inverse, type in the trig ratio, and you know the measure of the missing angle. Okay, we're going to practice it quite a bit. That's pretty much all we're doing today. So, this is what we talked about yesterday. I want to show you the difference between what you did on your homework and then what we are doing today. These help you find missing sides and angles if they're used properly. If they're not used correctly, then they're not going to help you at all. This is a page on your notes. I think if you flip back one, you don't flip the page, just, there you go. Alright, so, in the first, you're given the angle. The angle measure is 33 degrees. And you're missing the trig ratio. You don't know what it equals. In order to find it, all you would do is plug in sine of 33 into your calculator. On the second portion, which we are doing today, you don't know what the measure of the angle is. That's what x represents. In our problems, they're going to be a capital letter like A, B, C, D, whatever. Alright, so in this one, you're given the trig ratio, and it's 0.333, and you're missing the angle. So the inverse button is what you'll use in this scenario. In the other, you literally type it in your calculator as it is. So on the right, you would use shift and then sine, and sine to the -1 would pop up. And that's how you would solve that problem. The first one, however, you would just plug it in as it is. Okay? Just want to extremely show you the difference between the two. What do you get? 19.5? So if you put in your calculator sine to the -1 of 0.333, I already forgot it. What did you get? 19.5. Alright, so we're going to be predominantly using the left side, your right side, my left side. And then sine of 33, this is like a given question on your test, meaning I put it on there to be nice and to give you like an easy peasy question. Okay, so these are givens, and then this one you need to remember. Okay, so we're going to do these 3 examples. They are on your handout. Let A, B, and C be acute angles. Use a calculator to approximate the measures of angle A, angle B, and angle C to the nearest tenth of a degree. So letter A says tangent of A equals 0.75. Decimals and fractions are literally the same thing, because what is 0.75 in fraction form? 3/4. So it doesn't matter if it's a fraction or a decimal. It's literally the same thing. So in order to get angle A by itself, you need to get rid of tangent. The opposite of tangent is tangent. the inverse, tangent to the negative 1. So you're going to shift, tangent, and this will pop up. And then you'll type in 0.75. We are rounding to the nearest tenth. You should get 36.9. If you did not, then something's wrong. Letter B says sine of B equals 0.87. So to get B by itself, you need to get rid of sine. So you need to use the opposite of sine, which would look like sine to the negative 1. So you'll hit shift, sine, and then 0.87. What do we get? So you don't write tangent or sine again, you just write the answer. 60.5 is what you get. And the last is cosine of C. So the opposite of cosine will be the inverse. So cosine to the negative 1. Shift, cosine, 0.15. And you get 81.4 degrees. Are there any questions on how to do this before you do it by yourself? Okay. You guys are going to do this in your student journal. It's called a checkpoint because you're doing it and I'm not. Go. So 11.5 degrees. Number 4, 45 degrees. Number 5, 70.7 degrees. And then number 6, 62.9 degrees. All right, so all you're doing is hitting shift and then sine, cosine, or tangent. Questions about this? All right, so this is where we're actually going to start walking and solving for triangles. So go to this in your handout. This is solving a right triangle. Solving a right triangle. Okay, so solving a right triangle means to find all of the unknown sides, or side lengths, and angle measures. You can solve a right triangle when you know either of the following. So I've broken this up into 2 days. Bullet point 1 is what we're doing today. Bullet point 2 is what we're doing tomorrow. So this is a fill in the blank on your notes. To solve a right triangle means to find all of the missing sides and angles. So when you ask in a few minutes, why did we find this side if we don't use it? It asks to find all the sides and all the angles. Okay, you don't necessarily have to do something with them when you find them. It's just the answer. So the first scenario is when you're given 2 side lengths. This is the one we are doing today. This is the next box you'll see. The first scenario is when you have 2 side lengths. And the second scenario is when you're given 1 side length and the measure of 1 acute angle. So 1 side length and 1 acute angle. Alright, so when it says solve the right triangle, you're literally finding every missing piece. All the sides, all the angles, and that's it. So you're going to have 3 answers for all of these. Let's do our first example. It'll be below. It says solve the right triangle. Round decimals to the nearest tenth. So the first thing and the easiest thing that you can find is a missing side. How do you find the missing side on a right triangle? You've only written this down 2 or 3 times now.
A squared plus b squared equals c squared.
Thank you. And what is that called?
Pythagorean
The Pythagorean theorem. A squared plus b squared equals c squared. What are we missing? The hypotenuse or a leg? The hypotenuse, which is c. So 3 squared. So you should be writing this with me. Plus 2 squared equals c squared. 3 squared is 9. 2 squared is equals c squared.
13.
So 13 equals c squared. How do we get rid of the square?
Square root.
Take the square root.
Mm-hmm.
So c equals 3.6. So after this, I would not use this side again. Circle it and move on from it. If you use this side, you would have rounded once and then rounded again at the end of the problem, and your answer would be slightly off, if not completely wrong. So I would not use 3.6 again. Just put it on the side of your paper and forget about it for a few minutes. I use the information that was given to me, always. Because how many of us make dumb math errors all the time? I added something simply wrong, or I subtracted something wrong, or I wrote my 4 and it looked like a 1. Those kind of things. So I would not use this again. And what I mean by that, you're going to find the missing angles. You're going to set up a trig ratio. So it doesn't matter which angle you solve for first. I'm just going to solve for B because it's on the left side. In comparison to angle B, what kind of side is 2? Opposite, adjacent, or hypotenuse? The opposite. And what kind of side is 3? The adjacent. So what trig function deals with the opposite and the adjacent? Tangent. So you're going to write an equation. Tangent, from what angle are we coming from? B. Tangent of B equals, now we need to write our fraction. What goes on top? 2, it's the opposite. And 3 goes on the bottom. You are now equipped to solve for the measure of angle B. How do you get rid of tangent? The inverse. So the angle of B is going to equal tangent to the negative 1 of 2 over 3. Plug that into your calculator and write it on your paper. You don't have to say it out loud yet. Because in a few minutes you're going to do this all by yourself, and some of you do not pay attention or write anything down. We're not even on this page. We're on this one. Yes, sir. Which question? Oh, I thought you said question.
I said question.
So when you typed it in, what did you get? 33.7 degrees. That is the first angle, angle B. Now, there are 2 ways to solve this. But again, if you got this wrong, angle B wrong, and you used it to solve for angle A, you would get them both wrong. So when you're first starting out, I would do the same thing that you did for angle B, I would do it for angle A. How many degrees fit inside of a triangle? 180. There's already 90 taken up by the right angle, so B and A should add up to 90. So technically, you should be able to take 90 and subtract 33.7. But again, if you got 33.7 wrong, the next answer would be wrong as well. So I would do the same exact thing again, but from angle A. From angle A, 3 is going to be my what kind of side? Opposite. And 2 is adjacent. So which trig function deals with opposite and adjacent? Tangent again. So tangent from the angle of A equals the opposite, which is 3, over the adjacent, which is 2. So angle A equals tangent to the negative 1 of 3 over 2. Now type that into your calculator. Should get, what was it, 56.3. Now, I know I got this correct because I am your teacher and I've done this 3 times today. But if you added them up, they equal 90. But again, you don't want to do that shortcut until you are very comfortable and very confident in what you're doing. That makes sense?
Yeah.
Because if you get one part wrong, if 33.7 was wrong and all you did was subtract 90 to get angle A, then they would both be wrong and you would be stuck. All right, we're going to do 2 more together. We're actually going to do number 7 first. Number 7. So that's the right side of the page. If you flip your handout, we're going to do number 7 first. We're given 2 sides. How do you find the third side in a right triangle? The Pythagorean theorem. You're both correct. One was just saying it. So, the Pythagorean theorem, what is missing, a hypotenuse or a leg? A leg. The most common mistake in this is that students solve with the Pythagorean theorem wrong. 109 is your hypotenuse. So when you do a squared plus b squared equals c squared, 109 needs to be your c. So my 2 legs squared, 91 squared plus x squared, will equal 109 squared. What is 91 squared?
8,281.
8,281. I remember the other one ends in 81. I don't remember the rest.
11,000.
11,000?
Yeah.
881? Subtract 82, 81. X squared equals 3,600. How do I get rid of a square? Square root. So x equals 60. So whenever I circle it, I wouldn't do x equals 60. I would name the side, which was GJ, or JG, I don't care. The reason is I made up x, and whoever is grading this, most of the time me, sometimes my aide, if I don't see it, it will get a mark wrong. You know what I mean? So write GJ, so that it's very easily seen. All right, now we're going to find the angles. I don't care which one we find first. We can find H first, for all I care. 109 is the hypotenuse. We've already decided that. What is 91 in comparison to angle H?
Adjacent.
The adjacent. So which trig function are we going to use? Which one deals with the hypotenuse and the adjacent? Cosine, yeah. So cosine, from what angle are we? All right, and then my adjacent is 91. My hypotenuse is 109. How do I get rid of cosine? The inverse. So shift cosine will pop up, cosine to the negative 1 of 91 over 109. What do we get?
33.4.
33.4. Good. No, I want to practice one more time just to show you the difference. Angle G, we're going to check it. Because again, you show work, remember? Angle G, 91 will no longer be my adjacent. What kind of side will it be then? My opposite. Again, you don't want to use 60. You don't want to use 60 because you could be wrong. I've already seen 2 kids who didn't listen to me last class, and they got the rest of the problem wrong because they got this part wrong. Okay, so again, I wouldn't use this. I would use the 2 sides they already gave me. What trig function deals with the hypotenuse and the opposite? Sine. Sine from the angle of G, so sing, equals 91 over 109. How do we get rid of sine? The inverse, perfect. So sine to the negative 1 of 91 over 109. Yep. 56.6. You guys are going to try number 6. Some of you are acting very confident, and some of you are just not doing anything. So I'm gonna assume we're understanding. So you guys try number 6.
These are done.
I heard she don't take it. She really don't take it?
If it's finished, you can put it on top of that geometry book.
I mean, we know my foot, man.
They give you some crutches? Yeah. They give you some medicine? They give you a brace? What they say wrong?
Thank you for your help.
Honestly, I really don't care. You know what I'm saying? The room.
More.
So do we do